3, 2, 1. Let's go! I'm the host of the PBE podcast, Troy Tittlemeyer. We're at the 67th annual SPWLA Symposium, Lake Conroe. It's a fascinating group of folks, right? We had over 400 abstracts submitted for this event. The top 150 between technical talks and posters were selected to deliver this information and ideas and breakthroughs that we're having from petrophysical, wireline servicing, well log analyzing point of view, which as I learn more and more about this industry and this specific niche of petrophysics, it's really the integration point between drilling. You got drilling mud fluids that are really important, the hole, and what's beyond the other side of that casing and cement, and how are you getting commercial hydrocarbons. So your reservoir engineers, your completion engineers, your geologists, everybody's kind of going back to what we do, which is at the SPWLA, get that information from the hole. It's reliable. We can make sound decisions from it. Tony, please introduce yourself to the audience, and I look forward to learning more about you.
All right, yeah. So my name is Tony Vanzolum. I'm based here in Houston, Texas. I work for Halliburton, and I'm what's called a product champion, and I'm a champion of formation testing for Halliburton.
Okay. Where does it begin? Your passion for rocks?
Well, not so much rocks.
Oh,
okay?
come on.
I come from an electronic background. So it all started in Australia over 40 years ago.
Wow.
And I actually worked for an operator for a short time. I worked for SO Australia. And then I moved on into the wireline logging field with a company called Gearhart, which eventually became Halliburton.
Whoa. So you were brought on originally by Hess?
No, by SO.
SO
Australia, which is basically Exxon.
Okay. And what did they hire? So you're an electrical engineer?
So I was actually pretty lucky. SO hired me and then paid for me to go to college.
Whoa.
So the sad part was, when I wasn't at college, I was offshore. So I was basically offshore at quite a young age and joined the industry, a long time ago.
Wow. How interesting. 40 years ago?
More. 47 I started in the industry.
47 years ago. You don't look old enough to say that.
Some days I do. But no. It's been a fun ride. It really has,
Yeah, no, it's awesome. That's I can tell, especially because it's like, hey, will you do a podcast about this? And you're like, yeah, So that in itself is like, okay, you know what you know. You're excited about what you know, and you're excited about your contributions to these technologies as they progress. And you got to experience that firsthand. 47 years ago, what was wireline like? It was mostly fixing the tool and making sure it can even survive the hole.
Actually, to be perfectly honest, it was just moving into the digital age, right? So, in fact, Gearhart came out with the first digital platform with recording and stuff. Before that, it was actually analog. So it's been a good journey, but interestingly enough, the challenges are still the same. We've still got to discover the pay. We've still got to prove the pay's there. We've got to do electric logs to understand it. We've got to develop the field. So actually, the job itself is basically the same. The technology's got better.
Yeah.
We can do so much more now, but really the basic information we collected back then was the same.
So you're born in Australia. Parents are engineers, geologists, oil and gas finders.
Father's in the milk industry. He's passed away now, but he was an engineer.
Let's take a quick break from the show for a sponsor spotlight.
As an operator, you know that geomechanics play a massive role in the difference between a successful frac and a wasted stage. But are you still relying on uncalibrated models? The energy transition truly means moving from guesswork to precision, from generic outcome to optimized economics. Integrity In Situ delivers the world's most advanced geomechanical data set using their Insight tool subsurface acquisition platform, and is the first and only company capable of physically measuring stress and strain at differential pressures over 12,000 psi without injecting a drop of fluid in both vertical and horizontal boreholes. Capture real-time physical calibrations for your closure pressure and stress magnitude when you need it and where you need it. Unlock your frac's potential and increase production with less effort. Visit integrityinsitu.com and catch our latest technical deep dive with them on PBE Podcast.
What if your data actually worked for you? Upstream Plus, starting in accounting, built from over 16 years experience solving reporting challenges, reconciling complex oil and gas data, and turning fragmented information into clear, actionable insight. Because in this industry, the problem isn't a lack of data, it's the lack of clarity. Today, Upstream Plus is redefining what an LOS should be. A decision command center for operators, non-operators, mineral and royalty owners to protect assets, save time, improve decisions, and restore accountability down to the well level. Because in oil and gas, clarity isn't a luxury, it's power. Upstream Plus, see your operations clearly, decide with confidence.
He was an electrical engineer, but in the milk industry. He helped build factories and processes.
Oh, wow.
Mother was a stay-at-home mum.
Okay.
But yeah, he's actually was an immigrant. He's Dutch. He immigrated to Australia after the war.
Whoa.
So spent most of all of my school life travelling with them in a few different states. And then, as I said, basically got hired by Esso, put me in university, and then after that I joined in the oil field proper.
Wow, man, interesting. So, your background at Esso, or your position at Esso, was?
That was computers, which were very new then, so computer systems. And so the computer systems back then, they took up like the whole room, right? And they were mainframes. We actually had custom mainframes. And then we moved into Honeywell, and there was different languages, so that was very cool. But I was mainly hired as communications. We put in microwave systems, we put in communications, monitoring of all the rigs. And so, my whole job then was basically all purely electronics. But actually at that point, because I spent so much time offshore, I was offshore when I was very young, I was actually exposed to wireline logging.
Yeah.
And it sort of caught my attention. I'm thinking, man, what are these guys doing, And of course, the logging engineers were all rich, right? Back in the day, right? And it caught my interest. So actually, when I got to the end of my time with Esso, and I graduated, I actually moved into the wireline logging field. In fact, I actually applied for all the companies, and I chose ultimately Halliburton at the time. And
wow.
They've looked after me very well ever since.
Wow. So you're still in Australia at this time?
Yeah, still in Australia, but so I joined in the wireline, worked all over Australia, lived and worked in northern Queensland, which was going and blowing at the time.
Wow.
And
from an oil and gas perspective?
Oh yeah.
Really?
Yeah.
In Queensland?
So
what's the university up there?
It'd be like University of Brisbane or something like that. But I went to school in Victoria and Melbourne, and I went to college there. But at that point, most of the oil was produced in Bass Strait, and Bass Strait had a lot of rigs, and that's where I worked when I first started work. But actually the land operations, conventional wells up in Queensland, in the outback Queensland, was quite busy. In Central Australia, Moomba was quite busy. And so those were actually the on-land plays.
Where's the Bowen Basin? Bowen Basin? Is that
I don't know the Bowen Basin. But
I might be saying it wrong.
I've left Australia
okay.
in 1989, so I haven't lived in Australia since then. So.
Okay. So when you got your first opportunity to run wireline, what was it? Gamma ray, resistivity, neutron densities?
We ran a lot of dual ladder logs. Because of water-based mud, density neutrons. I actually tested some of the early dielectric tools there.
Oh, wow.
We were running formation testers back then as well. So yeah, I mean, it was a pretty full complement. We were running dip meters for imaging. I know you had a podcast with imaging, so we were running imaging tools with what was called dip meters.
Dip meters. This is the idea, kind of a from one side of the wellbore to the other, you can get. If the bed's dipping, you'll be able to see.
So it's a resistivity tool, but the imaging tool's got so much better now. But it's the same concept, is that you measure the resistivity off multiple arms, and of course you look at what direction the faults and stuff are traveling, right?
Because the resistivity anomaly in this sand layer is
different to this, and you have directional package and stuff like that. But that's what I said at the beginning. It's interestingly enough, the data we collected back in the 80s was basically the same as what we collect now, and we're collecting it with like computer systems that had 30K of memory back then, but basically the challenge is the same. Where is the water, where is the oil, how thick is the bed, what pressure is it at? So it's actually the technology comes along, but it's the same challenge.
Wow. So as a young professional getting into industry, what was surprising to you about how operators found oil, looked for oil? What was it with the data that was interesting? Like, so the combination of gamma ray with the neutron and resistivity crossovers, this is gas, that's oil, understanding what they were doing.
Well, it was interesting because I started off originally very technical, repairing equipment and stuff, but they pushed us to become to do logging, become field engineers, and actually do interpretations and stuff. So even though I was on the electronic side, I was forced into becoming a logging engineer because they felt the more broader understanding you had of the measurements, the better.
Wow.
So I'd actually do both, and of course I'd do like rotary coring because I was more mechanically minded and more formation testing. And as you said, back in those days, maybe you had to repair stuff on the well site, right? Because it was pretty old technology. But so really, I got involved in that. So it was interesting to me to see, it's like a puzzle, right? You get all these clues.
Yeah.
And then you put them together and you figure out what's there. So in fact, I think it was a real benefit to me early in that career when I was really just repairing stuff, to what actually come out of it. Like how do you use this data? How is it?
Wow.
And I think that really helped me as I went on in my career.
Yeah.
Because it gave me a balance of how to use that information.
Man. Yeah, that's such an interesting take. You know exactly how the tool's physically built, where the sensors actually are, real, like not a diagram, not a schematic cartoon, and you never see it, and you just lower it down the hole and see what happens. You know every inch and a thing about it.
And it's similarly with our field engineers, we want them to understand electronics and understand hydraulics and mechanics, because it makes them broader. So, if you look at a field engineer, a wireline field engineer, people say, well, you've got to be a geologist for that or a petrophysicist. No. That's good for sure, but we want you to, we really don't care which degree you have because we're going to teach you, have these intensive training courses. We do them in Fort Worth, and we teach you the skills of the industry, right? So really all you're proving to us is that you can learn.
Yeah.
But you'll get a guy that's a mechanical engineer, you've got to teach him electronics and vice versa and stuff. So and of course you learn naturally, learn the petrophysics because that's the industry you're in. So you become a very broad skill set, especially back in those days.
Yeah.
You're working remote, you didn't have cell phones, you might have a shortwave radio.
Yeah.
You had to think on the ground. You had to really act on what you could do.
Wow. And so back to the point you were making. So when you collect data, and the tools are supposed to be collecting the data they're designed to collect, and little things can go wrong where the data is contaminated, right? There's something happen, and it's not measuring what it was supposed to be measuring, and now you're going to try to cram that into these other data sets that now are not making sense. The complexity of taking data, reliable data, making sure it's QC'd, and then getting it integrated with everything else so you can solve the puzzle.
Real-time QC is important, right? If you're collecting bad data. So the field engineer has to QC in real time, right? You got to make sure the log that you're pulling makes sense, right? And there's tools that we teach that. So to be honest, with most electric line logging or formation testing especially, you've got that chance to collect the data. If you leave the well site with bad data, it's all over. You can't really fix bad data. So you've got real time. So obviously, as technology improves, now we real time stream data to multiple eyes, multiple experts, and we make sure it's good in real time. Back then, it was the field engineer and his guidebooks that would help him, but now we stream that out. So wireline logging, they talk about, well, we can just relog it, right? For instance, if you get a parameter wrong, you can fix the parameter and relog the data. And that, that's like if you haven't entered something correctly. But if the underlying data is bad, recovery is very... Now, in my business, the pressure and sampling business, you can't fix the data. If you don't collect good quality data or clean samples or wait long enough to collect the derivative as you're doing a build-up for deep transient testing, there's no fixing it. Right?
Wow.
You have to do that real time. So it's very, very important to have that real time expertise, which is now a lot easier because you've got the internet. Back in the day, you would fly everyone to the rig.
Oh my gosh.
And have everyone there real time to make sure you collected the right data.
Wow.
That's why, back in the days, you spent a lot of time on the rigs.
Yeah. Wow. Pioneering the development of all this stuff and
It's a lot easier these days.
huh.
I can look after 2 or 3 jobs at the same time
Wow.
from my office at home if needed.
Jeesh. So when you develop your career, you start. Halliburton is now you're progressing with them. They're putting you in more and more higher levels, more responsibility, more on. Are we getting the data that we need, and is it reliable? And how are operators using it? But then you also have at the same time, how are we changing this tool to make it better? What new things can we do? So how much of both of those things have you been doing for Halliburton, and for how long?
So, I've worked in a lot of different roles around the world. So I've been lucky enough to travel and live overseas with Halliburton. So I've done both operational and technical roles, and I've done mixtures of both. So, it's interesting. You go into frontier locations or remote locations, and so it's the whole package. So not only do you have to have the technology, but you've got to have the maintenance, you've got to have the reliability, you've got to have the ability to operate safe. So I've done operation leadership positions, I've done technical positions, but that's sort of the broad experience that you get over the years that lets me move into my current role, which is a product champion. So the product champion, I work between various different groups. I work closely with the customers to develop solutions. So when I go visit a customer, the first thing I ask is, okay, what do you need help with? What are you challenged with? I could just sell them what we have, but that's not what I want to know. I want to know, because when I do that product champion role, they give me a challenge, and then I take that back, and of course working with the management that I've got,
team,
we strategize, okay, what's important, what's not important, what are we going to get the technology team to work on? And of course I work with them on a daily basis as well, and I'll go to them, hey guys, we need to do this, and we'll brainstorm, right? And sometimes, there's several. I've been lucky enough to be in this role for quite a while. I could actually meet with customers and say, remember when we talked about that? Remember when we delivered that? It's good to sort of see from a concept to a delivery, right?
Yeah.
It's really, really good. So I sort of bounce between, I work with technology, so I'm seeing these really, really smart engineers and scientists and mathematicians develop new things, and then then I'm also looking at how we're using this equipment to discover, and then I'm also working with customers saying, well, what can we do different, or how can we do something better? So, and of course when I come to this conference, I'm walking around, I'm meeting all the colleagues and people that I've worked with over the years.
Yeah, catching up with old friends. How did that project work out? What did you learn from that?
And in high consequence, high profile jobs, I know that, with product pressure and sampling, nearly most of the companies have pressure and sampling experts or SMEs. So I have a relationship with them. So during high-end operations, we'll work together on the planning. We'll work together, and then in real time, with the magic of the internet, we can actually monitor that, collaborate in real time, make changes in what we're going to do based upon what the reservoir is giving you, because the reservoir gives you what it gives you. It's not going to go by your designer service. It's going to go by what it is. So sometimes you've got to completely change what you do, and that's one of the things we like about our product, the Reservoir Examiner, which the Examiner Deep is built on top of. It's really flexible. It's got a lot of flexibility. So when I talk to a customer, I say, hey, I may not have the solution for you now, but maybe I can piece these things together and come up with a solution. So it's a really rewarding job to do.
What's the history of the Examiner? You guys trademarked this name. When did this begin?
Examiner goes back quite a few years.
Okay.
When we were coming out with these new technology, the imaging technology, the NMR technology, there was a decision back then to brand the Examiner.
Nice.
And the Examiner for us now, the Examiner is our open hole FE solutions.
FE.
logging solution, right?
Okay.
So that's when you hear Examiner, that means it's our latest technology and on our latest platform.
Wow.
So that's how we differentiate what is the newest equipment.
Okay.
We have other brand names for cased hole, well intervention, and cased hole logging, but the Examiner is the open hole.
Open hole, latest and greatest.
Yep.
And so, what is the Examiners? Is it a suite of logs, like a triple combo of specific tech?
No, not really. So the Examiner is the name we give for like Examiner. It's not really triple. Triple combo is actually sort of like the standard technology. So if we do imaging, and you spoke with Peter about the imaging, well, that would be the Examiner.
Examiner FMI,
Yeah.
Examiner Sonic, Examiner Resistivity.
Yeah.
Okay.
Right.
Okay.
And so with my product, we have the Reservoir Examiner, which is our new generation formation testing platform we released a couple of years ago, and we released that to be the platform that we build everything new on top of. So a Reservoir Examiner tool string will measure formation pressures. We'll be able to get high quality samples. We'll be able to, and it has various different source probes for different quality rock and so forth, right?
So this tool goes, you lower it down, you want to isolate what we think is the zone of interest based on, while we were drilling, we got shows, maybe you ran some wireline before the Examiner reservoir. What'd you call it? Examiner reservoir testing?
Yeah, Reservoir Examiner.
Reservoir Examiner.
So the workflow is basically you will get your base logs.
Got it.
Essentially your triple combo logs. Now that could be collected with LWD or wireline. So you get your base logs, and then of course that will give you an understanding of the reservoir, right? Generally after that, in a standard workflow, you may do imaging, you may do NMR, and various other things, or maybe you do a spectral gamma ray or a mineralogy type log.
Yeah.
And you generally, so the normal workflow is you collect that enough data, or the data that you need, that will allow you to run the formation tester. So to run the formation test, you have to know what's there.
Yeah.
So sometimes that may be just the triple combo from LWD, and other times, depending on the reservoir complexity, you may need the NMR or you may need the image to better determine where to test.
Yeah.
So once you got that information, then you'll look and say, okay, how many zones do I have, or where does the reservoir exist, and what do we need to do? So again, sometimes in LWD, they will do the pressure testing to understand the pressure of the reservoir and the gradient being what fluid is in those zones. That may be collected with LWD, or it may be collected with LWD and wireline. So we generally do a pressure survey to understand the pressures, the overbalances, what fluids are in place. Then after that, we'll do sampling. This is all again with the Reservoir Examiner. We'll do sampling, and the different source probes will depend on the rock and the fluids and the mud system. So we've got a whole portfolio we can use to be able to extract that reservoir fluid from the rock and get it to as clean as we possibly can, so that you want it to be less than 1% preferably, or even non-detectable, because you put those samples in a bottle. You also analyze them using downhole fluid ID for composition and density and so forth, and capture the bottles. Now the bottle essentially brings to surface, now you have proof of hydrocarbons in place.
Yeah.
And of course, that can be sent off to laboratories and more detailed analysis.
So does the Reservoir Examiner go down and set packers and isolate? Okay.
So the Reservoir Examiner has various different probes. So we might set a probe against the formation to measure pressures, and also to pull reservoir fluid from the rock using downhole pumps.
Wow.
So the downhole pumps have various different ratings and various different capabilities. And that's one of the systems when we go to the Examiner Deep. That's one of the improvements that we go for Examiner Deep, which we'll talk about shortly. And then you'll have other probes that might have larger flow area to be able to flow faster, to clean up quicker. We have other probes that focus the flow to get ultra clean samples. So there is a portfolio there that you use. And you might run, for instance, the Reservoir Examiner can run multiple of these source probes in a single run.
Wow.
So you might have a high perm zone and a low perm zone, or you may even have a zone that you need to microfrac to understand the fracture, or you might want to do caprock integrity. All of these things can be actually combined in single runs. So when you talk about formation testing, it's a whole bunch of different pieces that we put together to essentially meet the customer's objective, and that changes from well to well.
How much influence have you had on this Reservoir Examiner, and to the point before you get to the Reservoir Examiner Deep, just the progression of that tool? Were you involved in that hands-on for many years?
Yeah, I've been involved in that since a lot of years. I think I started in that job in 2005.
Wow.
In what's called our technical services role.
20 years.
Then I went overseas to the Netherlands. I was technical manager in the Netherlands, but I was obviously focusing on expanding our formation testing. In formation testing, it is a pretty good chunk of the what we collect during an open hole job. It is definitely an important. So when I was lucky enough to come back from the Netherlands, I moved into my product champion role. So that was 2014. So I've been in this position for 12 years now.
Okay.
So. But it's interesting because obviously we work as a team.
Yeah.
So I'm not.
Yeah, you're not the guy.
I'm a little bit like the conductor.
There you go.
And there's definitely things I could say. Well, yeah, I push that idea.
Yeah.
But of course the whole team develops the solutions.
Right.
And we're very focused as a team. And it's good because it's not an individual program. If I have a guy working on it, I don't have to teach him what pressure and sampling is. They already know. And then when we look at new capabilities, like the Examiner Deep, that was an easy segue into, okay, here's our challenge, here's what we've got to do. And then we brought all those key people together to solve it.
And now introduce, so you get the progression and development of the Reservoir Examiner. Mm-hmm. You're learning what the clients are really wanting, what the operators are really needing to determine if they're going to go horizontal here or make this a commercial well, do all the different techniques that it's capable of doing. And then now you have the Reservoir Deep Examiner. So what happened there?
So when we built the Reservoir Examiner, we knew we were going to progress on to new probes and new technologies.
Let's take a quick break from the show for a sponsor spotlight.
As an operator, you know that geomechanics play a massive role in the difference between a successful frac and a wasted stage. But are you still relying on uncalibrated models? The energy transition truly means moving from guesswork to precision, from generic outcome to optimized economics. Integrity In Situ delivers the world's most advanced geomechanical data set using their Insight tool, subsurface acquisition platform, and is the first and only company capable of physically measuring stress and strain at differential pressures over 12,000 psi without injecting a drop of fluid in both vertical and horizontal boreholes. Capture real-time physical calibrations for your closure pressure and stress magnitude when you need it and where you need it. Unlock your frac's potential and increase production with less effort. Visit integrityinsitu.com and catch our latest technical deep dive with them on PBE Podcasts.
What if your data actually worked for you? Upstream Plus, starting in accounting, built from over 16 years experience solving reporting challenges, reconciling complex oil and gas data, and turning fragmented information into clear, actionable insight. Because in this industry, the problem isn't a lack of data, it's the lack of clarity. Today, Upstream Plus is redefining what an LOS should be. A decision command center for operators, non-operators, mineral and royalty owners to protect assets, save time, improve decisions, and restore accountability down to the well level. Because in oil and gas, clarity isn't a luxury, it's power. Upstream Plus, see your operations clearly, decide with confidence.
Such as Examiner Deep. So for me, again, as a product champion, I have to sell this to the product line, right? It costs money to develop new technology. So of course, I've got to have the voice of the customer. What does the customer need? What do they want? And of course, I sell that to our management, and they give me money to develop it. So that's the starting point. Is there a need? So the customer, with Examiner Deep, the customer voice was pretty loud.
Wow.
They want to, especially high profile, high consequent wells, they wanted better understanding of the reservoir. Now, if you look at the progression of pressure and sampling, pressure and sampling originally started off with, coring, cutting a whole core of the reservoir and bringing that to surface and see if there's oil in it.
Yeah.
And then, of course, they come out with percussion coring, where you shoot a bullet into the formation and then you can bring a rock sample up. That progressed to rotary coring. And again, so you're bringing the rock up, you can look at it, yes, there's oil in there. But the depth of investigation is quite shallow.
Yeah.
So in drilling the well, of course, that can be invaded.
Yeah.
So you could bring rock up and you could sort of think there's oil there, but you can't prove it. So the progression of formation testing was originally to measure formation pressure. So again, we set a probe, we essentially flow the formation a small amount of volume and measure the pressure build-up, and that allows us to understand the reservoir pressure. So if you know the reservoir pressure at this depth and this depth and this depth and this depth, now you can understand the gradient, which you can assume what the fluid in place is. Is it oil, is it water, is it gas?
Okay.
So that was the original formation testing to understand fluids in place using gradients. And that's a very effective tool, and we use this today. That's what I was saying. We used that in the 70s or wherever it was started, and we use exactly the same process today. And it's almost identical. The tool technology's a little bit cooler.
Yeah.
We have an enhanced probe section that can take multiple pressure measurements simultaneously to try and produce a gradient in less rig time, but the fundamental measurement's the same, right?
Yeah.
So that gets a little bit deeper, because you're pulling maybe 5 cc's or 10 or 20 cc's of fluid. So then in the 80s, I guess it was, they developed downhole pumps. Now you can actually pull the fluid from the formation and bring it into the tool and put it in a bottle. So now you can bring that bottle to the surface and you can say, yes, this is gas, yes, this is water, this is oil, right? But again, that's a shallow measurement. So I think don't quote me on the exact timelines, but I guess in the very late 90s and early 2000s, they figured out if you pump longer, so in other words, now you're pumping longer, you're getting deeper into the reservoir, right?
Yep.
Because you're producing that pressure wave through the production period of time while you're flowing the reservoir to get clean fluids. If you stop and do the build-up, now you can look deeper into the reservoir. You can understand better the permeability and potentially a few other attributes. So they called that, or we called it, and there's a few different names in the industry, but it was initially called mini DST. So now this looked a bit deeper. But the thing is, that wasn't deep enough to truly understand the reservoir. So what the historic way was always drill stem testing.
Okay.
Right? You basically run it on pipe, you inflate packers or you do it in case hole, and you flow the well for multiple days, you flare the hydrocarbons, and you can prove, does that zone produce, what's its productivity, does it deliver, and again, the same thing when you're doing the DST, you do the same thing. You flow for a period of time, and then you do a shut-in and a build-up, and that build-up lets you understand how big the reservoir is the
Kind
boundaries.
of volume you
right?
got. Okay.
So you had two things. You had mini DST on one hand, which is better than nothing, but not quite enough to really remove uncertainty. And you had DST, which is sort of the ultimate test, but sometimes challenging. You can't mobilize it to every single well, high cost. There is regulatory issues with doing it. So it would be great if you could do it every single well, but you probably can't afford to do it, and it's not practical. So the industry really said there's got to be something else in the middle. So that was the trade-off at the time. So the trade-off is, if I could pump faster, if I can pump longer and produce more hydrocarbons, in other words, to propagate that pressure wave out into the reservoir, then I can look deeper into the reservoir. Now I can get a better understanding of does this reservoir deliver? How big do I think it is, right? So you may not see with Examiner Deep, you can look potentially about 500 meters into the reservoir.
Whoa.
So, which is significantly more than previous technologies such as mini TST.
500 meters.
Yes. Now, that's, of course, dependent on the reservoir. It's dependent upon the test program, right? You have to flow for long enough to do that.
How long does that take? 500-meter test like that? It's
So-
1,500 feet, right?
Yes, yeah, it's actually a bit more than 1,500, but so it depends on your reservoir. So
Okay.
a lot of it's
Porosity
very
plan.
important to understand the deliverable of Examiner Deep technology by doing proper modeling. So the height of the reservoir has an influence. There's several other
Porosity perm.
things.
No.
Exactly. So as a generalization, your flowing period is, say, for 500 meters might be between 6 and 8 hours for the flowing
Wow.
period, and the build-up may be 6 to 12 hours.
Wow.
Right? So, but that's the key. So Examiner Deep, it has 3 components. So the first component is high rate pumps. Again, we've got to be able to flow at high rates. We've got to be able to produce a drawdown. So the drawdown's important. If you don't have a drawdown, you can't get a build-up. So you've got to have the signal to noise factor there. We also control that by the spacing of the packers. So we inflate a packer, the shorter the spacing between the packer, the bigger the drawdown, but depending on the rock, you may want to extend that spacing. So we have that capability. So you flow the reservoir, and then at the end you do a shut-in and you do a build-up. Now, essentially, to look deep out in the reservoir, you need to listen. So your pressure gauge is what's doing the listing as that pressure builds. So you have to have a high-resolution gauge. If you don't have a high-resolution gauge, that limits how deep you can look into the reservoir. So the first component is high-rate pumps. The second component is a high-resolution gauge. Both of those we developed new and to be allowed to plug into our Reservoir Examiner. So we didn't start with a blank sheet of paper. We started with something that was built to be expanded and expanded it. The third leg of the stool with dynamic deep transient testing is well control. So now you're pumping, with these fast pumps, you're pumping large amounts of hydrocarbon in the borehole.
Yeah.
And let's say worst case gas. But of course, hydrocarbons contain gas. And so essentially you do pre-job modeling to determine how you have to control that. But bottom line is you can't pump these large volumes of hydrocarbons in the borehole and then not control it. So we run this service most of the time on drill pipe, and while we're influxing hydrocarbons in the borehole, we are circulating them out at the same time.
Wow.
So we're actively moving the gas to surface in a controlled manner.
Right.
And
Not letting something,
not letting
formation damage potentially, or something.
Well, not
come
really.
in.
If you just pumped hydrocarbons in the borehole, there is a certain point that the hydrocarbons, you would take a kick, and your hydrostatic pressure, which is used to maintain the stability in the wellbore, will drop, and your well could start to flow.
Wow.
Without you wanting it to flow. So,
sheesh.
So there was a couple of things. The high rate pumps allowed you to pump large volumes of hydrocarbon. The high resolution gauge lets you look deeper, but the well control is an important part of that thing, because you've got to maintain well control, and so that's an important thing, and that's something that we communicate. This is a new technology. It's been around for a few years, but educating the drilling side of things and the well control of things is also another important part, and that's pretty effective. So, and that system, we have what's called a tool pusher system. This is the ability to attach wireline tools on the end of drill pipe.
Okay.
And you essentially run the cable down inside the drill pipe, and you make a connection called a wet latch, right? Now we've had that technology for a lot of years. It's common in the industry, but we had a really proven technology that could run formation testers on drill pipe. But what we didn't have was a system that would allow us to circulate fast enough to maintain well control. So it was good. Our segue was we had a great system. We just had to re-engineer it for the requirement of doing Examiner Deep testing.
That's pretty fantastic. That's interesting that the well control side of that obviously is a huge deal, because the pushback typically from a scientist's point of view or perspective in the room on what are we doing in this well, what data are we going to get from this well, how's it going to help us improve our profit margins on this well. You get you get the driller saying, hey, no, I don't want to be open hole. I don't want to do that formation test evaluation. What if we lose the hole? What if this happens? What if you guys have really thought about that, designed a way to manage that? And it's also data that if it does do it, well, okay, here's what it did. We controlled its kick. We float, we circulated, we managed the kick, we burn it off, and we...
So in this type of service, we never take a kick. And one of the main reasons is it's a little bit different. While you're drilling the well, you might take a kick because you're drilling into unknown.
Right.
During Examiner Deep, we monitor the hydrostatic pressure.
Okay.
We know how much influx is coming in the hole. We never get to a kick situation because to get to a kick situation would mean the hydrostatic pressure would need to drop below a certain threshold.
Yeah.
And since we're monitoring that in real time, we don't allow that to happen.
Yep, okay.
But it is the education within the industry that we're not going to produce that kick. So that there's a lot of, even though this has been around for a while, the important part of that education to make everyone feel comfortable and safe and understand what's going to happen during the operation is an important step. And in fact, that's a new learning curve for me. That was something that I never really got involved in, but it's an important step. So we do have full control. It's really more of a communication side of thing to make sure that you educate everybody. And once you do it, it's good because you do it, and you when I go to a new project, like I'm actually traveling here shortly to go to the next place we're going to run Examiner Deep. And the first meetings I'm going to have is about well control.
Wow.
Right.
How interesting. So your development of the Examiner reservoir, the progression of the original, the addition of the deep, the new things, right? The well control, everything you're talking about. It's fascinating. You're deploying it now. People are understanding the value that you're providing. Let's go do it. Let's get it into AFEs. Let's go deploy this. What do you see, or what are you most excited about, knowing that you guys are capable of going and doing this? Operators are going to use it. What's the next thing you see coming down the road?
So, to be honest, like anything with industries, the industry shifts, right? So this technology was really somewhat put out there to replace drill stem testing, right? And it's not really the case, in our literature. We say we're a scanning tool. We support, in some cases, drill stem testing.
Okay.
So, to give you a great example, and this is the shift that at least I've seen personally. Of course, when I come into this project, we went, well, this is the target market we're going to go. We're going to target exploration wells. So in an exploration wells, they're generally not going to bring a drill stem testing package on a well that they might have a 1 in 10 chance of discovering.
Yeah.
Right. But when you hit that discovery, everyone's disappointed. I didn't get all the information from the reservoir I could have got.
Yeah.
So the shift has been, and it's a lot due to the ability for the drilling department and stuff like that to understand this is a safe operation, that this extra time we spend in bringing more hydrocarbons in the borehole really adds value. It removes uncertainty from the well. So there's been a shift that it's more acceptable in the industry to do this type of testing. So I've got to be honest, I'm a little bit amazed how quickly that shift happened.
Wow,
right?
It's great.
Because it used to be, you could run a formation tester, you could set that tool for as long as you want, as long as it wasn't longer than an hour. or 4 hours, right? And you can pump out fluid samples and get clean samples as long as you don't exceed 500 litres, right? And of course, we're pumping thousands and thousands of litres now. So there's been a real shift, and of course it's from the industry has been educated. There, of course, proof is out there. While we're running these jobs, we collect endless data that you can demonstrate that everything is under control. So what we've seen is that we originally thought, well, this is going to be an exploration package only. But we're starting to run this technology in development wells. And here's the reason why. So they'll drill in, you're drilling a well, and there's always something unexpected pops up, right? I mean, that's why we run logs. If we all knew what was there, you wouldn't need to do it, right? And so you drill in, and all suddenly now you have 4 pay zones instead of 3.
Wow.
And one of them wasn't on your radar map.
Yeah.
Right? So wow, okay, well, they don't have a DST planned. They know if they do a mini DST, they're probably not going to collect sufficient data to really understand the reservoir. So now all of a sudden, because Examiner Deep is part of our Reservoir Examiner package, it's easily mobilized, or it may be already mobilized. You can mobilize it on a development well, right? And essentially prove that is that reserve economical? Does it produce? We can do productivity index. So with these high rate pumps, we can do what's called a step rate test, where we flow at various different rates and various different pressure drawdowns, and from that you can do an assessment of productivity and deliverability. And of course, when you do the build-up, you look at, do you see any barriers or connectivity? So now it does have a limitation of the depth of investigation compared to DST, but for instance, if you see a barrier at 20 meters, now you know it's quite a small pocket.
Yeah.
If you don't see a barrier, now you think this could be big, right?
Some volume.
And in fact, on one of our projects, they drilled a sidetrack well to chase that other zone.
Whoa.
On another project we're involved in, they went ahead and did productivity index on the 3 zones they were planning on perforating, and one zone showed to be, they changed their completion plan based upon the data.
Wow.
So we've had this, we have another project that had a drill stem test planned, and so there was talk of whether we would run the 2 services or not.
Yeah.
But again, they had an undiscovered, unknown zone show up, and it's, the main value of Examiner Deep, this type of technology, is if you have 3 zones and you're planning on drill stem testing the well, you'll straddle all 3 zones.
Okay.
You'll produce all of them.
Okay.
Because the cost of one zone, it's 3 times the cost to do 3 separate zones. But you might want to understand how does each zone perform.
Yeah.
Well, so with Examiner Deep, we can test individually those zones.
Whoa.
And so what they did recently, they went ahead and did the DST on the zone that they wanted to prove as part of their original plan. But we ran Examiner Deep on the zone that they didn't that they weren't expecting, and we collected that additional data. So that's why it's a combination. It can be a scanning tool. In some cases, if you have a discovery in an exploration well, if you test it with Examiner Deep, and you think this really looks like a good zone, it shows really good performance. On the next well, you'll mobilize the drill stem test package to fully understand that reservoir, or maybe on future wells. Where if the XDT test shows poor performance, you're probably going to drill another couple of wells to understand, what's happening, right?
Yeah.
So it's definitely and so that's the shift I've seen in the market, is where we originally thought it had a niche. That niche is broadening out, right? Where in fact, one of our customers, they're hungry for data, right? In their opinion, they need to take every single opportunity to collect high quality data on every single well, right? And they know if they do that, in the future they're going to be better off, right? But they can't do a DST on every single well.
Right.
It's not economically acceptable. It's regulatory to do it in the country this customer is in is very, very difficult. They still do them, but they can't do it on every well.
Permits, you got it,
So they said I can collect this minimal bit of information,
extrapolate,
but I can collect Examiner Deep, and now I've got more data, right? So they can justify that Examiner Deep acquisition where they can't justify the DST. So as people become more data hungry, and as reservoirs become, more difficult, more challenging, that extra data is worth it. So I've seen, for me, a real shift that this is becoming more of a common technology that would be run rather than specialized.
Yeah, it's flexible, right? It's flexible. Let's take a quick break from the show for a sponsor spotlight.
As an operator, you know that geomechanics play a massive role in the difference between a successful frac and a wasted stage. But are you still relying on uncalibrated models? The energy transition truly means moving from guesswork to precision, from generic outcome to optimized economics. Integrity In Situ delivers the world's most advanced geomechanical data set using their Insight tool subsurface acquisition platform, and is the first and only company capable of physically measuring stress and strain at differential pressures over 12,000 psi without injecting a drop of fluid in both vertical and horizontal boreholes. Capture real-time physical calibrations for your closure pressure and stress magnitude when you need it and where you need it. Unlock your frac's potential and increase production with less effort. Visit integrityinsitu.com and catch our latest technical deep dive with them on PBE Podcasts.
What if your data actually worked for you? Upstream Plus, starting in accounting, built from over 16 years experience solving reporting challenges, reconciling complex oil and gas data, and turning fragmented information into clear, actionable insight. Because in this industry, the problem isn't a lack of data, it's the lack of clarity. Today, Upstream Plus is redefining what an LOS should be. A decision command center for operators, non-operators, mineral and royalty owners to protect assets, save time, improve decisions, and restore accountability down to the well level. Because in oil and gas, clarity isn't a luxury, it's power. Upstream Plus, see your operations clearly, decide with confidence. I'm hearing all kinds of interesting...
That's one of the things we did, was because we made it part of the Reservoir Examiner. Now, if you've got to run 2 or 3 different runs, then it's possible to cancel the one run that maybe you don't want to run.
Right.
But if you combine them together, and you're running this on drill pipe, so since you're running it on drill pipe, weight doesn't become as big as an issue and stuff like that. So we're finding, in fact, the last 2 jobs that we've run, we've combined it with other pressure and sampling services. And on one particular case, it was a very high angle well. They would not have run 2 runs because they would have had run both of them on drill pipe, and they wouldn't have used the rig time. Because we could combine the 2 runs in one, they went, right, we'll run it. So the combinability really is an asset, especially as we're moving into a realm that I thought Examiner Deep wouldn't be considered. So that's the big interesting for me in the last couple of months. That's been an interesting learning curve for me.
Wow, and very interesting. That's exciting. It's exciting to keep going, and you got an industry of people who are hungry for this data and information, and now you're delivering it or making it more accessible, and it's reliable, right? We talked with Peter yesterday. I said robust, reliable, and repeatable, the 3 R's of Halliburton. And he was talking about imaging logs and all the different ways that's progressed. Now that you can run a resistivity imager with the acoustic imager at the same time, all these flexible ways
we run the imager on below the formation tester.
Really?
As well. So we'll do, for instance, there was a paper last year. The same tool string I'm talking about, we can break the rock, fracture the rock, produce fractures.
Wow.
And so we'll actually run Peter's imaging tool. We'll actually image the interval first, break it, and image after.
Jeez.
Right. So that combinability, we have the ability to combine coring with formation tester, imaging with formation tester. So that modularity is really a big benefit.
Yeah.
Because, for instance, if you're doing this fracturing, understanding how the fracture propagates is very important.
Right.
And historically, to convince someone, say in a deep water market, to do an image log, come out of the hole, do a formation testing log, come out of the hole, go back with an imaging log.
Yeah.
There's no. In fact, I know a couple of companies that have done it, but those poor SMEs had to beg on their hands and knees to get it done, and really the outcome was, well, this is great information, but the economics just isn't there. So the combinability really helps you there.
Wow. Well, thank you so much for taking the time, Tony, teaching us about the Examiner Deep. I look forward to staying in touch with you guys. Looking forward to any new papers that are going to come out with this, explaining and showing these case studies of its flexibility, allowing this data to be more accessible, to more operators, right? Get this data from the reservoir. Are you guys getting it from laterals as well? Can you tractor this out or somehow? And
we have run it up to 55 degrees, but we don't. This technology generally isn't run laterals, but we have done one job at 55 degrees because we're on drill pipe. We don't need a tractor. We just push it with the drill
push it
pipe.
out with the pipe.
So we have done horizontal formation testing before. So if there's a need for it, of course we can do it.
Yeah.
But we're working with customers. We should have a paper published very soon.
Nice.
So hopefully maybe next year's SPAA, but we'll be pretty active. We're working for several customers that like to publish, and they've given us their challenges. They've told us what they want to get from us for this technology, and
you guys rise to the occasion and get it done.
Well, we're always ready to do that. But yeah, we're definitely hoping to be busy on the technical programs next year for sure.
Great. Well, look forward to the progression of that and learning more, staying in contact. Thank you for your time, Tony, your dedication to this industry, giving back through this SPWLA platform.
Anytime I can talk about pressure and sampling, it's great.
You're in. Yeah, I'll take you up on it. Thank you
right.
again for the show.
Thanks a lot.